Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Okay, in this video, I would like to continue. This is episode number 3. Okay, I want to continue whatever that I have actually discussed previously under two series of video. Okay, as stated in the screen right now, I have actually discussed on the frame analysis of side sway frame using moment distribution method. Okay, in the previous two video, I have actually explaining about the concept of side sway frame, how we identify frame, it is side sway frame or non side sway frame, and then I have also identify about the condition. Okay, there are two conditions. One is symmetry, another one is called as properly restrained. So, and then okay, I have also explained about the principle of superposition, which is actually the principle that we use to analyze frame, frame, side sway frame, as well as beam actually. But so for side sway frame, this is very special because we analyze fixed end moment. We analyze member end moment or internal moment in frame. Okay, we have to analyze by using two tables, table number 1 and table number 2. We cannot combine, and each table, the difference is only due to the FEM value. Okay, and FEM is the first member and moment in the table. So for table number 1, FEM is actually identified or determined using external loading, and for table number 2, we actually assume FEM. We actually analyze side sway frame, but we assume FEM value. Okay, and that is why in the equation, the final equation to calculate end moment for the frame, okay, we will have correction factor. Because in the process we have to have a non-side sway frame in order to calculate end moment in first table, a non-side sway frame. Okay, and then from table number 1, we use static equilibrium to calculate R value. Okay, to calculate R value, and for table number 2 is side sway analysis. So actually, in what happened in table number 2 is we analyze frame which is proportional with the real side sway frame. Okay, the real side sway frame. So we actually interpolate the value. We derive one, okay, equation, okay, relate between m, r, m prime and r prime. So by using trigonometry and using interpolation, we produce m, okay, m in terms of r, r prime and m prime, and then we have, okay, and then we have the equation, okay, the final equation, the final end moment, which considering table number 1, which is non-sway frame analysis, and then table number 2 considering side sway frame analysis, and then we have correction factor. Correction factor is r divided by r prime. We calculate this r from both table 1 and table 2 using static equilibrium. Okay, using static equilibrium. Okay, so the summary of the procedure as shown right now, the summary. So actually I can summarize the process, the analysis using moment distribution method using 4 steps. Okay, step number 1 I have explained in my previous video. Of course, in moment distribution method, everyone must understand about K and the F, because K, EI, okay, EI, okay, contribute to the stiffness value. Okay, and we calculate distribution factor using K. K is member stiffness. Okay, and distribution factor we use to distribute moment. And the distribution factor we use for both analysis, means that non-side sway frame plus side sway frame. Okay, so and we have actually done uh, procedure number 2. This is actually non-sway frame, table number 1, table number 1. So in step number 2, we calculate FEM due to external loading. Okay, where external loading is given in the question, and from FEM we calculate end moment, member end moment, or internal moment, and this moment is actually we label as M naught. M naught. And then from static equilibrium, okay, from free body diagram as well as static equilibrium, we determine the value of restraining force. And the value of restraining force, we get it from shear equation. Okay, shear equation. From shear equation, we derive one equation to calculate R value. And after that, in the equation, there are two unknown, AX and DX. And AX and DX, okay, I have shown in my previous video, AX and DX can be calculated using what we call as column analysis. And after AX and DX are determined, then just substitute into the equation R, so we get R value. Okay, so now we want to move to, okay, now let's move to step number 3. Okay, for step number 3, okay, of course we need to have 3 subsection. Okay, same with subsection in non-sway frame, step number 2. So, but the difference is only due to step A, because this FEM is due to due to delta. This as FEM is due to side sway. So in side sway frame, we have to assume FEM. Okay, assume FEM. And this one is table number 2. Table number 2. And then this is the most difficult part in moment distribution method analysis, because once the FEM, okay, have been assumed correctly, so we just need to continue step B. Okay, end moment. This is M prime. Okay, this is M prime from distribution table. And step C, C is only repetition. Okay, the same process that we have actually done in 2C, except the values, all values are different. Okay, restraining force. Restraining force R prime. Okay, so the free body diagram for, okay, the free body diagram for step number 3, okay, we refer to this diagram. Okay, this diagram. So I want to copy this first. Okay. Okay, so this is the free body diagram for side sway frame analysis. Okay, we can see that the frame is subjected to R prime, so there will be delta prime, and we will produce n moment labeled as, the label is M prime. Okay, and the free body diagram for this frame, okay, we need to label as well. Okay, we should label as, okay, okay, so we should put the reaction at the support, the free body diagram. Okay, and moment. So here is M A or MAB. This one is MD. Okay, MD. So all these are prime value. Okay, we have AY prime. We have AX prime. We have D Y prime, DX prime, MD prime. Okay, so this is actually the free body diagram. Okay, but before we analyze R value, write the Shear equation for R prime. Okay, find AX prime and DX prime. So let's move to table first. Okay, let's move to table. Okay, we move to Excel. Because in my last video, actually for table number 1, I have shown the M naught or N moment in table number 1 we calculated using Excel. Okay, using Excel. So we move to diagram. Okay, we move to table 2. So we put this diagram first. This is the diagram, and then I want to copy the table, put it here. The FEM in the first table come from external loading, and the value is given in the question. But for table number 2, okay, for table number 2, okay, we have to calculate the FEM. Okay, we have to have FEM, but we don't calculate using delta value, delta value, because we do not know the delta value. We do not know also the delta prime value. So what we should do is we have to assume FEM. Assume FEM. So for this part, what we need to do is, okay, for the assumption. Okay, so let's look at this. So assumption, okay, since we have three members, member AB, member BC, member CD. So we have to choose member AB or member BC to start with. Okay, means that we will assume one value representing fixed end moment for one of the column, let's say member AB, and then we using ratio we will identify or calculate the FEM for member CD. Okay, so what we need to do is we have to assume FEM. Okay, we have to assume FEM AB, which is equal to FEM BA. Okay, since the frame is tend to sway to right direction, so FEM is actually negative. FEM is negative. Okay, why it is negative? It is because of the behavior. It is because of the behavior. Okay, if it is horizontal member, okay, deflect like this, we have to find the triangular. Okay, for FEM due to side sway, because we deal with delta, and delta is perpendicular with member. Okay, for beam element, beam is horizontal, delta is vertical. So the horizontal is original. So the angle we measure from original to incline to new position. So and the angle is clockwise. And when angle is clockwise, FEM will be anti-clockwise. So that is why in beam formula we can see that at fixed support A and B, the moment, okay, are both negative. Okay, negative. So this is a horizontal member. So beam is a horizontal member. So let's look at to column. Column is a vertical member. So what we actually do is we have to, okay, to find the triangular. Okay, the triangle. This is column AB. Okay, this is column AB. Okay, this is column AB. Okay, this is column AB. This is A, B. Remember that delta is perpendicular. Column is vertical. Perpendicular is horizontal. So delta is horizontal. This is delta. So this is delta prime. Okay, and the original position is vertical. So the rotation is clockwise. Okay, it is clockwise rotation. And FEM must counter back. So that is why the moment that we assume is negative. Because of the behavior. Okay, this is actually 100 moment. It is fixed end moment. Okay, it is behavior in order to push back the bend column, not deflected column, to its original position. So that is why the moment act like this. Okay, So what we need to do is we have to now apply the formula, and the formula to calculate FEM is 6EI. Okay, 6EI. If I'm not mistaken, it is 2EI. Okay, let me check. Okay, wait, where I put the EI. Okay, check in the table. Okay, wait, I need to check in Excel table. This one in K. No, constant. It is constant. Okay, it is constant for all members. Okay, constant means no to EI. All is actually EI value. Okay, so we move back to this. So it is 6EI delta prime. Okay, over L is 7 square, and this is equal to negative 100. Okay, this chord rotation, okay, the positive sign, okay, I put here. Okay, representing positive chord rotation. Okay, so it is 6EI delta prime over L squared, okay, equal to negative 100. So we arrange this, we simplify this, we get EI delta prime equal to negative 100 times 7 square divided by 6. Okay, so we use this EI delta prime in FEM for member CD. Okay, member CD. So for member CD, we have another triangular. Okay, we have, okay, move to right direction. Okay, move to, okay, in order to analyze FEM due to delta, okay, we always need to find where is the triangular. Okay, we need to find where is the triangular. Okay, so this is D, okay, D and E. Okay, and the delta is horizontal. Length is 5 meter length. Okay, length is 5 meter. Okay, so if we measure the angle, it is actually rotate clockwise. So this clockwise chord rotation, okay, clockwise chord rotation means that we will get negative FEM. So how to analyze this? We have to apply formula. So we apply formula 6EI delta prime over 5 square equal to, okay, wait, I need to write like this. FEM CD equal to FEM DC. Okay, this is equal to Okay, positive for angle. Formula is 6 E I delta prime over L is 5. L is 5. So solve this, we get solve this, we get 6 over 5 square. Okay, times with negative 100 times 7 square divide by 6. Okay, so this, so we cancel 6 and 6, and we will get negative. So this is positive, so we get negative value. Okay, it must be negative because the angle is positive. So when we calculate, we write the negative. The right sign means that this calculation is correct. Okay, so we want to calculate this value. Okay, we want to calculate this value. It is 100. It is 100. Okay, it is 100 times 49 divided by 25. Okay, we get 196. Okay, we get negative 196. 1 kilonewton meter. Okay, this is actually the value that we will put into the table. Okay, into the table. Okay. So it is 196 kilonewton meter. So this negative 196 is actually represent FEM, FEM for CDDC, and FEM negative 100 represent FEM for AB and BC. No, AB and BA. There's no value for beam. Okay, for FEM for BC, CB, because there's no vertical displacement. Okay, so we don't need to calculate FEM for member BC. So we put into the table. Okay, table number 2. Okay, table number 2. This is table number 2. Okay, I just need to change the FEM value. So we have assumed FEM for member AB. It is negative 100. It is equal for AB and BC. So we put that one, negative 100 and negative 100. And we don't have FEM for BC, so we move to CD. It is negative 196. Negative 196. Okay, negative 196. Okay, so let's check what is the answer. Okay, that's the answer. Okay, this is M prime. This is M prime. Okay, and this is M prime. So we can check the formula where we check whether it is calculating the right value. It is total moment. Total moment is 100 positive time with distribution factor. Where is distribution factor? Okay, we just need to double check the factor. Okay, okay. This is the factor. Okay, the factor. So this is 100. So this one. Okay, the factor is okay 0.417, so we get 41.667. That is correct, the correct one. Okay, this is 58.33, also the correct one. So okay, this the answer is correct. Okay, the answer is correct. So we get like this. Okay, for AB we get negative 88.49, and then negative 77.09, one negative, one positive, representing MB is equal to 0. And then we have MCB plus MCD is equal to 0, one positive, one negative. And then we have, for DC, we have the M value is negative 150, 151. Okay, so this value, okay, this value we use in we use this value in the free body diagram, okay, to analyze R prime value. Okay, so this is negative 88.5, negative 88.449. Okay, 88489, 44. So okay, this one. Okay, this is actually the free body diagram. The free body diagram. So now we know the M value. The M value. So okay, I just need to copy this again. Copy this again. Okay, so move to okay, we will do column analysis, shear equation and column analysis. So I put it here. Okay, so we already know the okay, this one I cannot uh okay, this one, let's check whether I can delete this or not. Cannot. This is the picture. Okay, so MA that we get from the table is actually 88.5 just now. It is negative. Okay, it is negative 88.45 0.5, negative 88.5. So we use that value. We use that value in this. Okay, so this MA is actually negative. Okay, negative. This is 88.5. 88.5. And for D value, it is negative 151. Negative 151. Okay, negative also. This is 151. Negative also. Okay, negative also. So actually we need this to write the shear equation. we need to write the shear equation. So for the shear equation, we have this fx is equal to 0. So from this we can write the equation. It is ax minus dx plus r prime no more. Okay, this is equal to 0. So we get r prime equal to negative ax plus dx. Okay, so this is actually the equation to calculate r value. Okay, so to calculate r value, so actually until this step, actually we just need to repeat the process that I have shown in my previous video, because our focus now is ax prime and dx prime, and ax prime dx prime we can get from column analysis when we consider column AB, column CD. So in column AB we have this 88.5, this one is negative 151, and then we should get also negative 77.1 for BA, negative 77.1 negative, and another value that we need to include is negative 106. It is negative 106. So we have ax prime and dx prime. This is 7 meter. This is 5 meter. So using static equilibrium, so we should be able to analyze ax prime and dx prime. Okay, so to do this, please watch again video number 2 and see how I actually calculate ax and dx, because the process is actually same with this. Okay, we just need to calculate ax prime and dx prime using column analysis, and it is just simple calculation. Okay, it is just simple calculation. Then we substitute ax and dx into this equation, then we get r prime value. So once we get r prime value, means that we have already determined, okay, all value in this summary. Okay, means that we have calculate, okay, FEM, assume FEM, we have done that. Okay, M prime, table number 2, we have done that also. And restraining force, okay, we can calculate also, because restraining force for C, both C are same. Okay, so now we have to move to step number 4. Step number 4 is actually the final formula. Okay, the final formula, which is actually we derive from principle of superposition, and it is m total, okay, which is equal to m naught plus, okay, plus the correction factor r divided by r prime. Okay, this one times with m prime. So in this equation, m naught is from table number 1, m prime is from table number 2. R we get from table 1, and r prime from table 2. Okay, from table 2. So having this, we should continue to calculate M final. Okay, maybe in table form so that we can calculate it easily. Okay, we just need to set formula to calculate MT. Okay, so once we have got all the value, then actually we can continue to draw diagram, shear force diagram and bending moment diagram. Okay, for the goal, for the objective, for the outcome of moment distribution method, until you can calculate up to this level. Okay, up to this level, it means that you have understand about what is analysis of side wave frame using moment distribution method. Okay, this is for type number 1, frame type number 1. Frame with side sway, there are three types. Okay, this is frame with vertical column. Okay, and we need to cover also frame with inclined column. So in my next video, I will continue. I will show to you how we analyze frame whenever the column is inclined. Okay, not vertical like this. Okay, see you in my next video. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.